where we will be doing the local infra setup for this entire mlops platform. Before touching any command, I want to clarify why this matters. In real world mlops, you don't need to run on laptop or notebooks. They run inside container. Those containers are orchestrated by Kubernetes, and some setup must work in development, staging, and production. Kubernetes gives us the consistency. By running Kubernetes locally, we get the production like environment without paying for cloud resources. And whenever we build here, and whatever we are going to build here, will later work the same way. It's guaranteed to work on AWS, GCP, or Azure as well. So now let's break down each component. We are installing one by one. So the first thing first, make sure to install the Docker. If you can install Docker Desktop, then that will be best. Docker is the foundation of everything we are going to do. When we run Kubernetes locally, the Kubernetes nodes themselves are created as Docker container. When you hear Kubernetes here, understand that Docker is doing the heavy lifting underneath. This is why Docker must be running like command like kind. So then it's possible. Second thing, for this specifically for the Mac user, they can install something called as Homebrew. It will be very easy for them to add packages. So for example, you can add Docker with the help of Homebrew. You just need to copy this command and come to your terminal and run it. It's that easy. So installing Homebrew is also very easy. You just need to copy this command. Make sure to come this website brew.sh. And Homebrew is simply a package manager for macOS. Instead of manually downloading the binaries and worrying about the version, Homebrew install tools like kind, kubectl, Helm in a clean and reproducible way. This ensures everyone following this course end up with the same setup. And now let's talk about the core Kubernetes tool that we are going to use. First one is kubectl. So let's search if we have the kubectl. Yeah, so kubectl is a command line interface for Kubernetes. Every time you run command like kubectl gets node, kubectl apply, kubectl log, you're directly talking to Kubernetes API server. Think of kubectl as your remote control of the clusters. And the next tool that we will be installing is kind, Kind, actually kind Kubernetes. So kind is the tool. Kind actually allows us to create fully functional Kubernetes cluster on our local machine. When we run command like kind create cluster, as you can see, it spin ups the Docker container that act as a Kubernetes node. So this is not a mock or simulation. This is real Kubernetes behavior, which is why it is perfect for learning machine learning MLOps correctly. So third tool that we want to install is the Helm. And Helm is the package manager for Kubernetes. In production, you do not manually deploy complex system using raw YAML file. Instead you install applications like MLflow, Airflow, Prometheus, Grafana using Helm chart, and this is what we are actually going to do. So uh, so let's do one thing. Now we have enough overview of this module. This is important module, and I wanted to make sure that every one of us have the right amount of tools ready for us to start doing this project. So first of all, uh, let's uh, let's first, once you have installed the brew, let's install brew, install kind, and we want kubectl and then Helm. let's let them install. So once the kind is installed, we are going to actually create our cluster, uh, provided there are the configuration is provided. So let's also do one thing, and let's take our first step and define the kind-config file. So meanwhile it is installing, let's define kind-config dot YAML. So here we do this kind. What we are going to do, we are going to make the cluster, and it's a good idea to define the API version. So the one I'm using is kind dot x hyphen k8 k8s dot io slash v1 alpha 4. So this is the version that I am following. And then let's define the nodes. And for defining the nodes, let's also define roles. It is going to work as a control panel, so let's also define the control plane. And then we need to do some port mapping extra. So what I am doing right now here is doing some port mapping, which is mapping the container port. So container port 330,000 to host port 8080. Oops, they need to be same indentation level. Host port protocol, that's pretty much standard stuff. You can type it. We are going to follow TCP, and then we also need to define, let's copy it. And now let's go ahead, and the next port, let's define 8081. Let's define their role as worker, and second role as also worker. So just make sure that these things are correct, and once this is done, our kind configuration is defined. Let's create our first kind cluster. So let's type the command CRE8 create cluster name, and we can name as mlops cluster 1, and we can pretty much create any name here. Then you need to provide the configuration path, the file that we had just created. We can provide that, and now it's going to do, oh, let's actually check if our docker daemon is running. I believe the docker container, yeah, docker is running. So it's saying kind experiment exited daemon failed to programming external activity on endpoint, control panel already allocated. Okay, all right. So what I understand, maybe the issue is actually we need to, since I'm running everything so previously, so there was some port allocated. Let me shut down. Mm, so now it's going to let me wipe off all of the previous clusters. So this thing can happen. You need to make sure that your so for you it's not going to create an issue. Just a local issue for me. Now it should work fine. And it's starting the control panel, installing storage class, and it's joining the worker node. So we are creating the mlops-cluster1 using this command. So this name is intentional, and what we are doing here is to, like, clearly we are trying to avoid accidental deployment to the wrong environment. And the file kind-config.yaml controls how the cluster is created. So it defines things like number of nodes, number of resource limited. This becomes important later when we deploy heavier services like Airflow, MLflow. And so yeah, after the cluster is created, let's verify everything is working. So let's come here, let's clear, and let's run the command kubectl cluster info hyphen context. We have to provide kind mlops cluster -1. This is the cluster we have created. So it is Kubernetes told us control panel is running at this port, and core DNS is running at this namespace kubedns DNS proxy, and that's really good. We were able to so what is happening when we run kubectl cluster info? We are checking the kubectl can communicate with Kubernetes control panel that we just created, and now let's run kubectl get nodes here. See, we are now what we are doing, we are confirming that the Kubernetes has active worker nodes in ready state, and let's see, it is in the same naming convention. Now let's quickly recap what setup we what setup that we have done is doing behind the scene. So first we check for the Docker if whether our Docker is running or not, and then we installed brew. For me it was already installed, and then we installed kind kubectl helm using homebrew. After that we created a cluster name mlops cluster-1, and then we ran some command cluster info get nodes. So now what we have done is created the clusters, and they are in the healthy state, and they are up, and every experiment tracker pipeline model deployment will run on top of this infrastructure only. So that summarizes the setup module 0, we can say module 0 of this tutorial. And now we can start doing the training cycle of this MLOps pipeline.